Guys, it looks like surfers might now have a way of drastically reducing their risk of a shark attack. And no, I'm not talking about those slightly dodgy shark repellent wristbands. Now, for years, there's been a tug of war between sharks and surfers for the ocean. Okay, surfers, and everyone else for that matter, won't see it as a tug of war. Sharks are absolutely the ocean boss, but undoubtedly there's still conflict. And with conflict, there's almost always loss of life, and for this example, that applies to both humans and sharks. In more recent years, scientists and innovators have been trying to find ways of reducing the conflict between sharks and humans with advancements in technology. And the more we've learned about the sensory systems of sharks, the more technology has been developed. But sometimes the best types of technology, the ones that really work, take their inspiration from nature itself. So come with me today as we dive into the world of shark deterrent technology. We'll look at the ones that actually work, and we'll find out exactly what scientists have cooked up in their lab this time for surfers to try out. Welcome back to another Shark Bytes episode, everyone. Now, there's no denying that surfers make up a decent proportion of shark attack victims. From memory, it's somewhere around 40%, and swimmers aren't too far behind that either. So from a demographic perspective, it makes sense for inventors to target these two groups of water users. And the first type of device that came to market was wearable shark deterrents, normally in the form of a wristband or an anklet. Some of these devices have now been on the market for over 15 years, and you've got companies like Freedom Plus Surf, Repellent, and the slightly more well-known shark bands. Of course, over those 15 plus years, these companies would have been tweaking those devices as the technology got better. But despite them being around for over a decade, the jury's still out on them. After the products started coming to market, it didn't take very long for incidents with sharks to start cropping up. In 2017, young surfer Zach Davis was bitten by a blacktip shark while surfing off the coast of Florida, while he was wearing a Shark Band's product. Slightly ironically, he'd got the wristband for Christmas and tried it out for the first time a few days later and was bitten. The entire incident, though, turned out to be a complete freak encounter, as Zach just happened to jump off his board, essentially on top of or incredibly close to that blacktip shark, which of course scared the shit out of it and it bit him in response. I'm only chuckling here because he was fine. He did have to have a number of stitches, but he turned out just fine. Talk about dreadful luck, though. On the flip side of that, though, there have been some more serious incidents which have resulted in fatalities. Peter Clarkson and Gary Johnson were both killed in 2011 and 2020, respectively, by white sharks in Australia while they were wearing shark deterrent products. In these examples, both of them were wearing shark shield technology, although it was unable to be proved whether the devices were switched on at the time of the attacks. So because of some of these fairly high-profile incidents, in 2018, a scientific study was led by shark scientist Charlie Hooverneers, which looked into the effectiveness of 5 of the different deterrent devices. This included all the usual suspects, Repellent, shark bands, Freedom Plus Surf, and they were being tested on the shark responsible for the most unprovoked bites on humans, the great white shark, and the results were variable to say the least. 4 of the devices, including Repellent and shark bands, were found to have limited to no measurable effect on the white shark behavior, whereas one of the devices, Freedom Plus Surf, had some effect, reducing the number of white shark interactions from 96% down to 40%. Okay, it's not the best, but it still had some effect. The founder of shark bands, though, Nathan Garrison, refuted the study, claiming it to be flawed based on the type of bait that was used and the distance of that bait to the device. He also claimed he'd had several calls down the years from customers stating that the shark band's device had likely saved their life. Since then, Charlie Hooverneers and his team of shark scientists have published more research on the topic, with the latest publication coming out as recently as summer 2024. This time, based on their findings that the Freedom Plus Surf device was previously the most effective product, they set out to test it against the 3 most common sharks when it comes to attacks on humans: whites, tigers, and bulls. And again, after those tests, they found the deterrent was effective at reducing shark bites across all 3 of those species by around 54%. Now, those numbers aren't bad, but they're nowhere near perfect. And it boils down to the fact that devices that rely on disrupting the electrical sensory systems of sharks have too many external factors to make them 100% reliable. You've got potential user error, i.e. switching the device off, like those 2 divers who were killed by white sharks in Australia, but you've also got external factors with the sharks themselves. The 3 sharks responsible for biting humans are so different to one another. White sharks, tiger sharks, and bull sharks all live in different places, occupy different niches, and have different hunting strategies. So you can bet the way their bodies work in relation to all of those things I've just mentioned are slightly different as well. And I've not even mentioned personality differences between individuals yet either. For example, some individual sharks are more shy and might be more easily deterred, whereas other sharks are bolder and might not be deterred at all. Those are all external factors that I've just thought of off the top of my head as well. I imagine imagine you'll get so many more if you dug deeper into the literature. And it's because of those factors that these devices will never give you 100% peace of mind. I mean, looking at those numbers there, 54%, that's still almost a 50-50 chance of a bite. But electrical disruption of shark sensory systems isn't the only potential way of deterring a shark. There's a few others that have been adapted from nature itself. Technological innovation is rich with biomimicry, which is the fancy way of saying adapted from nature. The natural world often has already perfected designs that can help solve human problems. One of the first of these came from the inventors of human flight, the Wright brothers, who regularly watched pigeons flapping their wings and were inspired to build the first aeroplane. Some of the more famous ones, though, include the bullet train in Japan, inspired by the aerodynamic body shape and beak of the kingfisher. It's not just limited to birds, though. Fish, including sharks, have also inspired human technology. Popular swimwear brand Speedo designed swimsuits inspired by the dermal denticles of sharks to reduce drag and improve swimming speed for competitors. And so it's these clues from the natural world that have, over the years, and more recently, inspired inventors to create products to reduce shark attacks. And one of those that you might have already heard about or seen is the banding or striped patterning. The banded sea crate, a type of venomous sea snake, has been mimicked by humans for over 1,000 years. This striped sea snake patterning has been traced back to tribes in the South Pacific from over 1,500 years ago, who used to paint themselves in black and white stripes to ward off sharks because they'd seen sharks avoid the sea snakes. In modern day, you might have seen surfers paint the bottom of their boards with this black and white striped patterning, or even wear wetsuits of the same design. And in practice, it seems like a smart idea, until you realise that some sharks aren't afraid of sea snakes. Tiger sharks have regularly been found with black banded sea snakes in their stomachs, suggesting that they aren't deterred by the venomous snake's patterning at all. But maybe it's not down to the sharks being afraid to eat something that's patterned like that, but more about disrupting how the object physically appears. Here, let me use an example to explain it to you. What's the first black and white animal that pops into your head? Now, I'm hoping that most of you said zebra, but even if you said penguin or panda, the lesson still applies. Zebra stripes are known to disrupt the vision of flies who might want to bite them and in turn pass on some nasty diseases. It's thought that the flies can't quite get to grips with the stripes as a landing spot and end up just bouncing off them. Some researchers have said as well that the zebra stripes can act as dazzle camouflage to lions, making them harder to distinguish when they're running in a group at high speed. So if you look at both of those things, the same could be said for the black and white striped sea creatures. Perhaps the stripes break up the outline of the animal, making it harder for the predator to see, or they confuse that predator as they're swimming away. You'll find dazzle camouflage and disruptive camouflage everywhere in the animal kingdom. Now, there's not much out there in the scientific literature looking at black and white stripes or disruptive patterning on surfboards, but scientists from Australia have recently tested a similar hypothesis with LED lights, once again taking their inspiration from nature. Down in the very deep ocean lives a shark known as the velvet-bellied lantern shark. This small shark in the dogfish family is only little, and as such is at risk of predation from larger deep-sea animals. But to evade capture, the lantern shark possesses a unique strategy in terms of camouflage. On its velvety underside, the lantern shark has a number of photophores, cells that can produce bioluminescence. And it's this green/blue light that allows the lantern shark to almost disappear in the downwelling light when viewed from below by predators. This particular process, known as counterillumination, is seen in some other deep-sea animals, including bobtail squid and some shrimp species, all of which can be prey to larger animals. The strategy is most effective against predators that have relatively poor vision, and especially those that lack colour vision. And one such predator who fits that bill is the great white shark. Dr. Laura Ryan, who's well known for her research into shark sensory systems and shark attacks, has recently published a study testing this counterillumination hypothesis, and she's had some fairly convincing results. Laura and her team decided to place strips of LED lighting on the underside of sealed decoys to see if it would impact whether sharks attack that decoy or not. They tested the LED decoys for over 500 hours in Mossel Bay in South Africa, dragging them back and forth over the deep water channels where white sharks like to hunt from. It's thought from a vision perspective, white sharks will rely on seeing a dark object silhouetted by a light background. But when they flipped that around with the LEDs to create a light object on a dark background, the sharks didn't seem to recognize the object as a prey item. They found that a few evenly distributed horizontal strips of LED lighting on the bottom of the decoys, like you can see here, was much more effective than the other pattern designs that they tested. It was so effective that the ones with this design didn't have any interactions from white sharks at all. Zero. And so Laura and her team are now in the process of testing an actual surfboard prototype with LEDs fitted to the bottom of it. That of course comes with its own issues like the overall performance of the board, the size of the LEDs, and the battery batteries required to power those LEDs. As always with any research paper, I like to look at them with a critical mind, and for this one there are 3 drawbacks/questions that I'd be asking. The first is that this has so far only been tested on one of the 3 shark species responsible for the majority of bites on humans. To be fair to them, the scientists do point this out in the paper, and until it's tested on the other shark species, we don't know exactly how effective it's going to be on them. The second question or concern that I've got though is the timing and the location of the study. Now obviously Laura and the other scientists from Macquarie University have trialled this in South Africa as opposed to Australia, and that's probably because of a couple of reasons. The first is that it's a bit harder to trial something like this in Australia because of the conflict between sharks and humans there. And secondly, the sharks in Australia don't really tend to breach out of the water when they're hunting. That behaviour is almost exclusive to South Africa. So they've gone to South Africa to do their trials, but unfortunately for them, their timing was pretty poor. The study was done in Mossel Bay from 2014 to 2019, almost exactly around the time when white sharks basically disappeared from Mossel Bay because of those killer whales. That right there would have undoubtedly had an impact on the amount of data they'd have been able to get. Sure, they managed to get some interactions, we can see that from their figures, but I do wonder whether their sample size here might be on the slightly lower end of the scale. And finally, the third thing that I'd have some questions about is the overall hunting hypothesis. Laura's study here relies almost solely on the vision of white sharks, like most of her other studies, and it doesn't take into account any of the other sensors that they might be using for hunting. And so the research leans quite heavily into the mistaken identity hypothesis, which of course does have some flaws. And if you want to hear my thoughts about that, I tell you all about it in this video right here. Seamless transition. In it, we take a look at some of the other hypotheses as to why sharks bite humans, and I take a deeper dive into the mistaken identity hypothesis and show you some of those flaws. So make sure you give it a watch here.